What I'd like you to do is just draw a line right here where the arrow is. Because now I want you to start thinking of these equations as having two sides, which you actually already did, right? What are these guys known as? Starts with an R. Reactants. What is this side called? Products. Good. All right. So we have our reactants and our products. And last night, since all of you did your homework, Law of Conservation of Mass, there was like 2 people. So you probably want to knock it out if you missed it. But Law of Conservation of Mass says that it has to, you can't lose it. It can't be created or destroyed in a closed system chemical reaction. So just like that, we're going to make sure that our chemical equation also shows that. So looking here, what we're going to start with is we're going to label who our characters are here in our reaction. So remember, our elements are everything that has a capital letter. So yell out one of the elements that you see in this balanced equation. Not balanced equation, your chemical equation. What's one of the elements that we're dealing with?
Chlorine.
Good. Great. Chlorine. What's the other one? What's another one? Hydrogen. That's it. Those are the only 2. All right. So we have chlorines and we have hydrogens. Whether they are in a diatomic thing or they're in an ionic looking thing or acid thing, whatever, we don't care. It's just those are the elements involved. Okay. So now what we're going to do is we're going to look at each side and we're going to count what we have. So we practiced counting atoms the other day. This little 2 right here tells us that we have 2 of those, right? So remember the subscripts. All right, so how many chlorines do I have on my reactant side? 2. So I'm going to put a 2 right here. All right, on my product side, how many chlorines are there? There's only 1. Okay. Now we're looking at hydrogen. How many hydrogens are on my reactant side? 2. How many hydrogens are on my product side? Only 1. All right, good. So, in order for this to be balanced, it means that we couldn't have lost things along the way. All right, so this right here is an example of an unbalanced reaction. So just label it as unbalanced. Because now our goal is to fix that. So you don't have to turn your page. I'm just going to put a page up here. What are the things that we can use to balance things? I'm going to put this page right here. Okay, sorry, I might have said it. Sorry, coefficient. So a coefficient is what we're going to be adding to our little equations in order to balance these things out. So just again to make a point. All right, so we see we have 2 versus 1, 2 versus 1. So looking at this little equation, is there a coefficient that we can add to it in order to make these things maybe be equal? Is there a coefficient that I can throw up here? Remember, coefficients, the way they work is they multiply by all the ones that are behind them, right? So you stick it onto a little compound or an element, it goes for everything behind it. Which H? Because there's H2, Cl2, or HCl. HCl. What do you want to put there? Probably a 2, right? So if we were to put a 2 right here, you can add that to your page as well. If we were to put that 2 there, remember it applies to everybody behind it, just like we were practicing the other day, right? So now what that means is that I have 2 chlorines and I have 2 hydrogens. So looking at this, I have now balanced my reaction, my chemical equation, okay? Because these numbers are what are equal to each other. Atoms before and after are equal. Not subscripts, not coefficients, atoms, all right? Atoms have to be equal. Okay, so atoms have to be equal to each other. So that's the thing that you're trying to balance. That's always a test question we like to tell you. Okay, we try to throw you off and say the coefficients have to be the same. Don't get thrown off by that. All right, so the other thing that I'm going to have you write with this is something else that I want you to get used to writing, and that's going to be a mole ratio. Again, we don't know what a mole is yet, but I want you to start using mole ratios. And what that is that we just list out the coefficients. So looking through this whole balanced equation, we're going to list out what the numbers are that we have for each one. How many Or what's the coefficient in front of the H2? If it's blank, what does that stand for?
1.
So 1, okay. What is it in front of the Cl? 2. It's also a 1. Since it's blank, it's a 1. And what is it in front of the HCl? That's the 2. So we have a 1:1:2 mole ratio. We put the 2 there so that we can make these numbers equal what we had before the reaction.
So we don't put any other number.
Nope, just that 2 there because it applies to everything behind it. Okay. Now, today,